Let me go quickly and introduce the panel. So we have Dr. Jeff Alstott. He's a program manager of the IARPA, the Intelligence Advanced Research Projects Agency, which is part of the Office of the Director of National Intelligence. With Major Nathaniel Bastian, PhD, who's the Chief Artificial Intelligence Scientist at the JAIC, the Joint Artificial Intelligence Center. And I'd like to give you a little more detail on that in just a second. Then we have Mr. Paul Milsom, who's a Master Principal Software as a System Solution Engineer for Oracle. And we have Ms. Gretchen Stewart, who's the Public Sector Data Science Technology Director for U.S. Enterprise and Government, the Sales and Marketing Group for the Intel Corporation. So it's a real pleasure to have all of you here, and very looking forward to the conversation. So as I think we said, as I mentioned earlier, I had a chance to listen to the earlier panel sessions. And the earlier panel sessions, they really started out with just kind of a basic definition of what machine learning is, went through some potential applications of it. There was some conversation of security concerns. And then the last one, they're really trying to talk about what do you need to do to operationalize AI for the edge user. A lot of talk about data and data management, these kind of areas. What I'd like to do in this panel, we talked about this, was focus on two issues that may not be focused on enough. In fact, one of the panelists of the first discussion even said, this whole AI security space may not be getting enough attention. And then the other area that I'd like to talk about, and I think there's another area that gets some attention, maybe not enough, is really if we're going to efficiently use AI, how do we do the teaming with men and machines? And in the first panel session, there was a reference made to AI beating chess champions, beating Go champions, these kinds of things. What we also know is that some average players have beaten computers when they have used advanced computer systems as well. And what we found is that the human-machine teaming gives advantages over just plain AI systems. And I'd like to, if we have time, to get into that as well. What I'd like to do then is to start out, if you don't mind, and give kind of a broad contextual background. And to do that, I'd like to start out, Nate, if you could start talking to the JAIC and some of the overarching things that you're looking into, and then we'll drill down into some more specific topics.
Yeah, absolutely. And I do apologize. I've had some technical difficulties today with my video, so I'm going to try to keep getting it to work at government computer. So, but I will dig in. Hopefully everyone can hear me. So the JAIC, just for quick, who we are, where we are, the Joint Artificial Intelligence Center, we fall under the DoD Chief Information Officer, which is under the Office of the Secretary of Defense. And we really were created to help execute the 2018 DoD AI strategy. And one of those kind of pillars of that is sort of committed to leading in military ethics and AI safety. And actually, as part of that strategy document, it says that in order for DoD AI systems, to deliver them, they must be safe, secure, robust, and that we're going to fund work into systems that have lower risks of accidents, are more resilient, to include hacking and adversarial spoofing and the like. And so in general, when we're thinking about the resiliency of AI systems, in general, we can bucket these into adversarial AI, which are sort of countermeasures that adversaries might deploy against our AI systems, and then the evaluation steps and defenses needed to safeguard performance. And then also trustworthy AI, which is those procedures, practices, and measures to ensure AI performance is accurate and reproducible with characterized limitations. And so when we look at specifically adversarial AI, typically it's important to consider well, first, these types of AI systems, for example, a computer vision system, they see, very differently than humans, right? And it's all about mapping relationships between features and in unintuitive ways, right? And so adversarial techniques can really uncover those relationships and craft inputs, if you will, to elicit a desired response. And so in general, we typically have an access paradigm for how we view the sort of landscape of adversarial AI attacks. think of this as the knowledge that the attacker has of the targeted AI system. And typically we bucket this into three sort of categories. The first being a white box paradigm. And so in general, in this type of access, the adversary has a complete knowledge of that AI implementation of the AI system, the state, software, data, weights, input and output values, anything, sort of just all knowledge about sort of the model and the overall system architecture in general. Whereas in a black box paradigm, the adversary has no access to the internal information of the AI system, but what they can do is they can repeatedly probe with different input-output pairs to infer what that inner state is. And then third is the hidden box paradigm, and this is where the adversary, they make some assumptions about the AI model, including its existence, sometimes by just observing, or it can be revealed through its overall system behavior. And so given these sort of three paradigms, in general, we can bucket these into three types of attacks, or three categories. Now, there are some more emerging ones, and they start, binning these into new emerging ones. But the main three that I know Jeff from IARPA is very focused on, and I am as well, to Jake and those on the panel here. But it really comes down to poisoning attacks, evasion attacks, and model inversion attacks. And there are some new ones, like I said, emerging. But in general, a poisoning attack comes down to an adversary polluting the training data to skew the decision boundary and the overall model behavior. Okay, and so this is really it's common in systems that must rely on observations in the operational domain for its training data. Jeff's program, Trojan AI, it's about these Trojans, so it's poisoning the data that's used to train. So, for example, if you think of an AI used for spam detection, this can be trained on adversarial user input. User feedback would incorrectly classify some types of spam emails as non-spam emails. This could be really hard to prove due to the prevalence of different transfer learning techniques, that have come up in other pre-trained algorithms. So that's focused on the training, poisoning the data used to train a model. When it comes to an evasion attack, this is probably the most common adversarial AI use case. In this evasion attack, the inputs are engineered. We call these adversarial examples, but they're engineered to cause the classifier to assign the input to an erroneous class. So this is a model that's already been trained, and now it's an adversary is trying to sort of fool that classifier. And so the third type is model inversion. This is the least publicized attack category. It's often the most difficult to execute, but it carries some serious privacy and data security implications. And so in this type of attack, an attacker repeatedly probes the AI system to extract information about the model configuration or the embedded training data. So think of this as kind of, hey, I probe the system and I kind of reverse engineer sort of the learning that took place to extract, hey, what data was used to train this particular model, for example. And so in general, those are the three types. And so I guess I'll pass it back and I'll try to get my video working. Over.
Jeff, I want to go over to you. Could you talk about, Nate gave us some background on what the types of attacks are. Could you talk about the impact of some of those, what some of the consequences are, and then go into some of the research that you're doing to try to understand how to mitigate, to characterize and mitigate those things?
So the consequences of an AI misbehaving are purely defined by what you've hooked up the AI to, right? So if you have a spam detector for email, the consequences of somebody having sort of used or put in a security hole into that, or just a normally occurring error, are going to be that someone's going to get some spam that they weren't otherwise supposed to get. That is unlikely to be a huge issue. If you had, say, a lethal autonomous weapon that was running around in a battlefield, then the consequences could be much greater. And in fact, if you had any sort of military defense system that was being used in peacetime, but was critical to the decision to go to war, that would be even worse, right? So it's purely determined by what you are using these things for. And I'm very thankful that the Department of Defense, with their AI ethical principles, has identified the sort of scale element of this, and that this last element of we need to know when things are going wrong and being able to shut them down is, if they're misbehaving, is really a great one. So of the AI ethical principles, the last one is governable, and that's the one that I'm most excited about because it requires the Department of Defense to be able to know when their AIs are misbehaving and to be able to sort of pull the plug on them. And thus that would prevent us from getting into these situations where an AI has a heck of a lot riding on it, because if we had a security or safety problem occur, then it could be very bad. So I'm thankful the Department of Defense and the intelligence community has been thinking about this for a while.
So what are you doing at IARPA regarding this?
So as Nate mentioned, I run research programs on AI security, AI for computer vision, and other things. And the AI security program that I run is TrojAI, standing for Trojans and Artificial Intelligence. And what we're trying to do is detect if an AI has a Trojan or backdoor put inside it. And so this could have come to be because some bad person got into your training data and manipulated it. So that's data poisoning. It sounded like half of the people who responded to the poll were sort of cognizant of that. It's worth noting that technically speaking, you could put in a Trojan not by manipulating the training data, but by doing surgery directly on the neural network. That's only been shown in a few toy examples so far, but it is a prospect as we continue to advance our understanding. So if you're concerned about backdoors or Trojans, you could say, well, I'm just going to protect my data and I'm going to protect everything about the development process so that no one can get in there and put in a backdoor. Good, you can do this. But that whole supply chain running into your AI is really very long, very distributed, and reaches back to China and other places when you talk about the chips and the algorithms that are being used and the code bases and so on. So we have taken the approach of we're not going to try to prevent attacks from happening. We just want to know if it happened. Because if you know that there's a backdoor, then you can take actions to mitigate that. The problem is that basically no one on the planet knew how to do that up until relatively recently. And so the people who now have some semblance of an idea of how to do this are IARPA funded researchers. And I'm very happy to be running a team of people from 10 different research institutions and companies around the United States that are working on this problem. Our testing and evaluation is being done by NIST, the National Institutes of Standards and Technology, and you can look at our TrojAI leaderboard to see what the latest that's being done by IARPA-funded researchers and others to try to address this problem. And it's an area that really is not just at the cutting edge of AI security, but interacts with other issues of AI security. So Nate was talking about adversarial examples or evasion attacks. So AIs can screw up due to adversaries having deliberately put in backdoors, but they can also just screw up because they're screwed up, right? They just errors happen, and sort of naturally occurring camouflage or optical illusions that can fool AIs happens in them already. And so for our TrojAI program, we have built up a code base that lets us produce thousands of AIs that are clean or have backdoors in them. And so then we use this as our test set to say, can you build a Trojan detector? Show me which one's which, right? And we had an issue that many of these AIs were just sort of like naturally producing errors anyway, these naturally occurring optical illusions or camouflage, these adversarial examples. And it made it really tricky to figure out which one was which because they were both screwed up in different ways, right? Thankfully, the state of our understanding of AI security has advanced a lot in the last few years. So we started developing AIs using the latest training techniques to squash down and mitigate these adversarial examples, these naturally occurring issues. And so our clean AIs look a heck of a lot more clean. And so now there's more signal that lets you distinguish whether or not an attack has occurred. And I think that this is the kind of understanding that we're going to have in the future, realizing that the state of play of security is going to continue to change and advance. And so that will both enable us to do certain things and disable our ability to do certain things that were working. So that's part of what makes it a very intellectually interesting field to be in, but it's also very nerve-wracking when you think about actually using these things for safety or security critical missions.
Thanks for that, Jeff. I'm interested, I want to go to Gretchen real quick, but I am interested at some point in understanding, how cyber security has the kill chain that's been developed, is whether or not there's an AI security kill chain, right, for the various different types of canonical attacks that Nate mentioned. But let's get back to that later. Gretchen, so you exist at kind of the intersection of the hardware and software, right? You do both of these. How from Intel's perspective, how from your perspective, are you thinking about some of these security issues?
So first, thanks for having me as part of this. I will continue to learn every moment as we're all discussing. But I think part of what Intel tries to do first is a public-private partnership. So we already work with folks from IARPA. We have jointly invested in a number of AI research centers with the NSF. We also work with NIST in terms of designing and looking at what the right standards are to ensure that hardware and software are really designed in that way. So you think about the hardware itself, and we look at how can we encrypt to the highest level each component, whether it be memory, whether it be CPU. Can we even do that for peripherals that maybe we don't even build, but that somebody else builds? And we go literally all the way back, think of, as we were talking about zero trust or a fully trusted environment, all the way back to the components that are building. So to build our silicon, you're talking about sand and lots of other components. And we go all the way back to ensure that we understand where we got those and how that goes through in terms of the whole build process. And when we're talking about components that we built in, like the ability to create a secure enclave so that you have the ability from a VM perspective to target a certain amount of core, not all the core, but some of the core in the CPU, memory, storage, and peripherals as an example, and ensure that those are encrypted. So creating those kinds of things within the hardware and then providing the software tools that sit above that. So kernel libraries, all the tools that like a SAS or that Google will leverage from a TensorFlow perspective and help optimize all of those to ensure to take the capabilities that are built into the hardware so that you have that combination of hardware and software that are really ensuring and creating the encryption that you need. And also, if we do see something, that we absolutely move it off any kind of track to be able to be processed from a hardware perspective. So again, we understand it's about both. And we want to absolutely ensure that from the bare metal perspective, that all the tools that sit on top of it are taking advantage and are ensuring that they have the highest levels of security.
Are you comfortable with, do you think this issue is getting enough attention right now? And what do you think are some future directions we should take as we're looking at the integration of the hardware and software, trying to assure, you're talking about from supply chain perspective, but going forward, what are some things you think we should be thinking about?
Well, I know that we are definitely looking at that intersection of software and hardware, that, you can't, a lot of the AI applications are developed, and I think somebody earlier had talked about lots of times they develop them on a cloud. And then they take that information and maybe use it in a private environment that you've got in your location. Or maybe it's a combination of a multi-cloud environment plus some of the information locally. So how do you ensure that you've got the right storage and that you've tiered it in a way that you're ensuring that it has the right encryptions, and that if you're encrypting or decrypting, how do you ensure across the entire data journey that that's really happening? So when we're designing or thinking about sensors or things that we've designed at the end, like edge, like VPU, et cetera, how do we ensure that that is encrypted? And then as it moves along the journey, maybe to a gateway where the gateway wants to decrypt, look at that, decide to take some actions or not take actions, re-encrypt, and then move it along the way. So those are the things that we're looking at. And truthfully, we know that Intel doesn't have all the answers, which is part of the reason why we continue to work with IARPA, or we are creating those AI centers, because it is a public-private partnership. And we want to ensure that what we design is the most secure and the most capable to help everyone who's trying to build the best algorithms that they can, or leverage the algorithms and frameworks that are already available.
Thank you, Gretchen. And that was a great segue to Paul to talk about cloud, right? So Paul, when Oracle's thinking about security, we're kind of moving up the stack, right? So now we're thinking about the cloud instantiation of these tools. What kind of security concerns does Oracle have? And what are the mitigating steps that you take?
Thank you very much for the invitation, and pleasure to be here. Tremendous learning experience. And again, from the Oracle perspective, the concerns around cloud, essentially you think about the cloud from the standpoint of security. We're doing a lot of being able to put embedded AI into our applications, really being able, and particularly around anomaly detection, to be able to take log files, activity, session activity, location, business activity, business user, to be able to take all of that data, to be able to analyze it, and then be able, based on that, to be identifying anomalies. It's interesting, we kind of step back for a second, you look at a lot of our customers, they don't have maybe the resources, the technical resources, the ability, the data to build models, to be able to build those on their own. So what we're doing is building a lot of that, both at the database level. So our database can detect and can repair based on attacks, both in the middleware level, and then also in the application level, where we can be able to analyze transactions within the application, to be able to identify anomalies, and then be able to direct that to the appropriate person based on the appropriate risk profile.
So are these specific tools that you develop for the anomaly detection in your cloud, or this is where you're leveraging other tools?
These are actually in our cloud. These are tools that we have developed and put into our applications. Again, because for the majority of our customers, it is very difficult to be able to develop these tools, to be able to develop the logic, to be able to train the models, and to be able to deploy those. And so we want to be able to develop an application stack that's really self-detecting, self-repairing, and one that has those controls embedded into it.
So thank you. One thing I'd like to just kind of pose to the panel, I think it was 1998 that there was a group of hackers called the Loft that went to the Senate to try to warn the Hill about the dangers of cybersecurity. From that time onward, we made a lot of advances in the knowledge of cybersecurity and tools and these kinds of things, detection methods, mitigation, et cetera. Where do you think we are with respect to AI security?
Not great. So I'm very amused at how you said 98. That makes sense in the context of the internet. But when I often tell people about how I see the current lay of the land for AI security, I often reference the 80s and the 70s, where people were building out IT infrastructure without a lot of thought for cybersecurity. And now we're dealing with the consequences of that today. And I don't just mean businesses buying solutions, but also the kinds of technology that people were developing, right? So it could have been the case that like memory buffer overflow attacks are just not a thing, but we made certain decisions several decades ago about how we design chips, and now we're stuck with them, right? So I would love it to be the case that we don't repeat that same sort of mistakes with AI. I think we are looking at a lot of great techniques for using AI, and we're eager to put these into different contexts. But unfortunately, some of them are sort of like fundamentally broken. And some of them are not fundamentally broken, but we really need to figure out how to make it more secure or more safe now before we go build a whole infrastructure, industry, et cetera, that's baking in certain ways of doing business. So that's what I'm trying to sort of head off at the pass. But thankfully, AI is really taking off, and so having a lot of effects. So it's sort of a race here between those that are trying to make the system more secure, safe, and those that are trying to use it for a mission.
Yeah. Can I add to that real quick?
Yeah, please.
Yeah, I think this is still very heavy in research and development, hence Jeff's program and others at DARPA and the different service labs. A lot of the focus to date has been mostly at the model level. So I think even from a system level, and we have multiple components to be different AI components, how do they, how do they work together? Having robustness metrics or certifications for a whole system, and many of those trade off from an explainability perspective, right? If we want trusted AI, well, it's sort of conflicting objectives, right? Maybe, we have robustness, but we also have safety and explainability and aiding to trust, right? So I trust it because it's robust, but I trust it because it's explainable. And a lot of times, many times at the at the model architecture level, those are trade-offs that you're making. And so we have a ways to go. So I'll leave it at that.
I appreciate it.
And to add on to what both Nate and Jeff have said, is you're absolutely right. When people really started to initially look at processor design, security was one of the things, but I'm certain that it was a little below the line, if you know what I mean. But now it is absolutely part of the design center from our perspective. And so there are things that we are adding not only into firmware, but into the hardware itself. And so when you really think about the multiple gates and how you need to really move throughout the processor, where really security is being designed in and creating enclaves and the ability to do those sorts of things. But you're absolutely right. Things like side channel and others where you could get in between user and kernel were not things that people even thought anybody would do. And so absolutely now the interesting part is we're a hardware company, but we have over 15,000 software engineers. And that probably wasn't true 20 or 30 years ago. Don't quote me because I didn't work for Intel 20 or 30 years ago. But you know what I mean? We've got a lot more software engineers and people who are really working intimately with the hardware to ensure that security is part of the design center and that it is all the way down to the hardware and that all those tools take advantage of what's available there so that somebody who is designing AI doesn't need to know all of that, but it is built in based on the tools that they're using.
Is there anything?
Build on this also, just real quickly. One of the issues we have is around data, and so many of the organizations that we deal with really don't have a lot of quality data. Data's in multiple systems. It's in multiple validation. There's no governance over it. And it often ends up being a data and data science, trying to repair all this data before you can even get to building the models and being able to test them. It tends to be a very difficult thing.
Well, let's pull on that a little bit. I mean, what are you seeing, this push towards the cloud, data lakes, these kinds of things. What are some of your concerns there? In the last panel, the first panel, I talked about data provenance, these kinds of things. What are some things that you think we need to be thinking about as we all start expanding into this distributed data environment? From a security perspective.
What I'm seeing for when people are really beginning to just define their data strategy, because you really do need one, and honestly, our chief data architect, chief data scientist lives in DC for the very reason that we're all on this panel together. The government has the most amount of data probably across the globe. And really ensuring from the beginning when you think about that data strategy, what is the security component of that? Is it 256-bit encryption or is it high? What are the components that you want to ensure that are built in from the beginning on your entire data strategy? And then when you're upgrading the infrastructure and so on and so forth, you're really ensuring that you have built that from the ground up, if you know what I mean. And that's what I'm starting to see people begin to think about. But it still feels like a multi-headed hydra, and people are not quite including security at the beginning where I think you really need to.
Yeah, absolutely. And you see that particularly a lot of my clients are in the Department of Defense, and being able to put data governance, just block and tackling data governance, understand where your data is, what the format of it is, being able to put controls over it. And then, almost with that, putting a data strategy in place that includes security is really important. And it's really kind of a fundamental step, at least in the DoD. I'm just seeing a lot of organizations really seriously undertake now.
I'm curious, Nate, the JIC has got a huge mission, huge charter, right? and you run to the CIO's office. How are you thinking about these data management kind of issues, kind of department strategically, if you will?
Yeah, great question. So under the CIO, we do have 5 modernization pillars, and I'll just use this to frame my answer. AI is just one of them. We also have cyber, cloud, command control, communications, and now data. So actually, as of 2 months ago, we now have a CDO, Mr. Dave Spurk, came up from SOCOM. And so actually just last week, I believe his office, which is just a couple of people, released the DoD data strategy. And so I'd say before data became a pillar, right, the Jake and a lot of our initial sort of products and just for situational awareness, we have about 35 AI products in the funnel at different stages across 6 verticals, spanning joint warfighting operations, joint information warfare, joint logistics, warfighter health, business process transformation, and missing one. Anyway, one other one. It'll come to me. But you can imagine a lot of these, I'll just call them, if we call them use cases, the majority of the effort has been a data digitization focus, right? The data is just not ready. What does that mean? Unpacking that, almost having a consulting model. You might have a lot of data, but is it the right data? So for example, we have a maritime search and rescue product lead that we're maturing. And it's like we're able to secure 20 million images, and it's like, well, how many of those images actually have one object that we care about detecting, let alone a lot of objects of over 100 different objects we want to sort of detect in an image, right? So we may have a lot of it, but is it the right data for this problem, or is it representative for whatever the use case? So that's been a lot of the initial seed efforts. Anyway, so the focus has been on data for AI product development. That's been the focus, but just data in general, we established a data governance working group within the Jake to make decisions on, what data do we ingest into our joint common foundation that we're building? What are we going to do with it? We piloted some best practices. So if you think of AI engineering best practices, one of the best practices is this data to model traceability, and to kind of, data provenance and those types of things. But to get after that, we leveraged Google's initial work on data cards and model cards to be able to get after, what is the data, and capturing all the sort of meta features of the data, not only to just store it and create a repository and also a catalog that others across the DoD can leverage and do a search from and see what's available, but also for data provenance purposes. We've done the same thing with model cards as well to track how a model, changes in versions over time. This has been extremely critical, very different than enterprise applications. But, a lot of the work we have to do, for example, one of our products we built in response to COVID-19, it's called Project Salus, and it's a humanitarian logistics sort of supply chain type application that we use to support the NORTHCOM commander and the National Guard Bureau leadership with a lot of the medical logistic type resource allocation decisions post disaster, post pandemic or during the pandemic. Key decisions around where are the hot spots going to be for food shortages or other medical supplies. Where do I send certain types of supplies and how many, how do I staff them? Those types of decisions, right? So we built, first thing we did was we built a data platform, and we searched and brought in over 70 different data sets, spanning, open source, stuff that different vendors gave for free, like, food supply chain companies, things like that, some government stuff, operational data. But first we had to build the data platform because it didn't exist, so we built the data platform in a way that then we could bring in, I think we ended up bringing in 7 or so different performers to actually build different AI applications on top of the platform. So you can imagine having to bring in 70 different data sources and from a policy side and understanding what is this data, what isn't this data, how does it sort of interact, not necessarily at the technical level, but on the policy level with other data sets, and especially in a situation where the DoD is supporting sort of a U.S. type operation, which typically we don't do, right? So we're kind of supporting FEMA, but not really supporting NORTHCOM. So there's a lot of sticky issues around just what we can do and how we can support, let alone the data and how they are fused together, and let alone the AI applications that we're building on top of this for different predictive analytics things. So data management for that was key. And so in building this data platform, a lot of the functionality we built into this was automating the construction of these data cards and model cards as new data sets come and go. So we've kind of, so we have a data management process here at the JAIC, and a lot of those lessons learned, we've sort of shared with the new chief data officer. He's gonna own data management and governance for the DoD. But when it comes to preparing and curating and conditioning, and just storing data, whether it be for AI or any advanced analytics that can be done, there's certainly a connection there. We're at the hip with that, and actually together, we're actually creating some new acquisition mechanisms to help the DoD help themselves with regards to data readiness, and we're pushing out a data readiness multiple award contract to help, like I said, the DoD components and services get their data ready across the spectrum of volume and velocity and variety and however many V's you want to use to make it ready, for themselves, let alone for the JAIC to help them with. So hopefully that answers your question.
That was a great answer. Really appreciate it. Appreciate that. So listen, we are almost out of time. So what I'd like to do is kind of go around, and if you could just tell folks, you may have seen the surveys earlier, the kinds of, we've got industry, we've got legislators, we've got former government folks, et cetera. We stuck to the AI security piece, data security. What's the last word? What would you like to have people take away from this panel session in that area? And we'll go in reverse order from start. Paul, we'll start with you.
I think that AI has tremendous potential around cybersecurity. I think there's still some limitations, and that they should continue to investigate it, and it'll continue to develop. But right now, it's tremendous opportunity, tremendous potential. Right now, I don't think it's a panacea of being able to take care of all the security needs.
Great. Thanks, Paul. Gretchen?
I think if there's one thing I could leave is there should be, and there always will be, a human in the loop. I think that there is a lot of great information. I mean, there are things that Oracle does, as an example, can do, not only compression, but can look and do dedupe so that you don't have 3 times the same amount of information because the data scientist keeps recreating things. But at the same time, when you think about the combination of the technology and the information, there really does have to be somebody who is looking at that and doing the compare, and who really has that domain knowledge. Because that's one of the other things I see a lot, is that you have a lot of people who are hiring data scientists, and brilliant people, happen to be one myself. But the truth is, you really need the domain expertise. So for Border Patrol, you need to really understand what those folks are having to deal with every day. And so the combination of great information and great data with a human is, that is the panacea.
Gretchen, thank you so much for bringing that up. That's an area, we talked about, would like to bring up, but I wasn't clear we had time to actually explore it. So thanks for bringing that up. Jeff?
So under the right conditions, with the right people and data and so on, AI can be very, very powerful. But with great power comes great responsibility. So we need to be aware that as we're using these AIs in very high impact situations, things going wrong could get arbitrarily bad to unlimited levels of bad, particularly if you're talking national security. And so we need to not be sort of eager to just get something deployed. We need to be very sure that we're not making the world or the United States a worse place by virtue of having some of these things deployed. Sometimes the answers to that are simply like have a human in the loop. And when that is both technically true and sort of operationally possible, that's great. that will not always be the case. And so sometimes the answer should be, yes, this AI can work in principle, but the risks of using it are simply too high in practice. And so we will not use it, right? That is sometimes a second solution. And then hopefully there will be third and fourth solutions where we have new technical sort of solutions for validating that an AI solution is really trustworthy. We're not there yet, and I'm hopeful that we will get there through the JAIC and Intel and Oracle, and IARPA will help too. But we need to be very measured in our assessment of when an AI is trustworthy enough to use it in a high impact situation.
Thanks, Jeff. Nate, you got the last word.
Yeah. So thanks for inviting me to the panel and meeting everybody here virtually. I'd say, just because we have AI doesn't mean we need it to solve a particular problem or to augment a human or accelerate, right? It's still a tool. It's all about decision making, problem solving, and making sure that we can help. If we need AI for this, great. Second point is, I'd like to see a little bit more research, so I'll put this in Jeff's lap, around sort of the human threat vectors from a human-machine team, right? We're always concerned about adversarial ML from at the poisoning level or evasion level or even inversion level. But if we're truly optimizing an AI system with a human in or on the loop, right, there's these human threat vectors that I don't know if we've fully sort of looked at. And I can give examples, but we're kind of running out of time. And the last point is, I'd say sort of in the same vein is that I just lost my train of thought. Basically, that those threat vectors are really a key thing for us to look at. So I'll leave it at that. And I lost my last point. So
Well, I think you're talking about giving examples of human-machine threat vectors or something. That might have been it.
Yeah. So if you think of like a car, right, a self or sort of semi-automated car with a human, right? We have computer vision systems that are able to sort of detect, how far the car is in front of it. And a lot of times that image then goes through a common filter and sort of creates a sort of other types of coordinates that a computer can use to understand how close we are, far away. And so an adversary, for example, through an evasion attack could put up some sort of patch or ghost image or et cetera to sort of change what those values are. And that could cause a human to make a decision, right? So there's this human sort of layer there that we have to consider. And that reminded me of my last point is this, from an adversarial ML perspective, we've always looked at these sort of static type attacks like at poisoning or evasion, but I like to see this area of sort of sequential adversarial machine learning. It could apply to reinforcement learning type problems, but just like, maybe an adversary wants to come up with an optimal policy of like doing certain perturbations or certain things, over time to cause some desired effect. So I'd like to see some research and development in that from an AI security perspective.
Great, thanks, Nate. He threw a lot at you, Jeff.
We're on it.
I want to thank all of you. It was a great conversation. I really appreciate the time you spent. Thanks so much. Over to you, Megan.